The discovery of Makemake was a significant milestone in the field of astronomy, marking the addition of another distant and fascinating object to our understanding of the solar system. Makemake is a dwarf planet, one of the 5 officially recognized by the International Astronomical Union, IAU, in the Kuiper Belt, a region beyond Neptune that contains many other small, icy bodies. This discovery, like many others, helped to further refine our understanding of the outer reaches of the solar system and added a new layer to the complexities of our cosmic neighborhood. Before delving into the discovery of Makemake, it is essential to understand the context of its discovery within the broader scope of the solar system. The Kuiper Belt is a vast, icy region, extending beyond the orbit of Neptune, filled with many small celestial objects that remain largely unexplored. These objects are remnants from the early solar system and are believed to be the building blocks of planets. Among the objects in the Kuiper Belt, a small subset are classified as dwarf planets, bodies that are large enough to be rounded by their gravity but have not cleared their orbits of other debris. The discovery of such objects has sparked ongoing debates regarding the definition of a planet and the classification of celestial bodies. The discovery of Pluto in 1930 was the first major breakthrough in understanding the Kuiper Belt. Over time, more objects were discovered in this region, including Eris, Haumea, Makemake, and the more distant Sedna. These discoveries have significantly expanded our knowledge of the solar system's outer regions, and each new object adds complexity to our understanding of planetary formation and evolution. Makemake was discovered on March 31, 2005, by a team of astronomers working with the Samuel Oschin Telescope at Palomar Observatory in California, under the leadership of Mike Brown, a prominent astronomer known for his work in the search for Trans-Neptunian objects. The discovery was part of a larger effort to locate and study objects in the Kuiper Belt, which was still a relatively unexplored region at the time. The team was conducting a survey of the sky to identify potential new objects beyond Neptune, and Makemake was identified during their observations. Initially, it was not immediately clear whether the object would be classified as a planet or a dwarf planet, but subsequent observations helped to confirm its status as a member of the latter category. Makemake is located about 45.3 AU, astronomical units, from the Sun, making it one of the more distant objects in the solar system. What makes Makemake particularly interesting is its size and composition. It is the 3rd largest known object in the Kuiper Belt after Pluto and Eris. It is estimated to have a diameter of about 1,130 kilometers, 890 miles, which is roughly 2/3 the size of Pluto. Despite its relatively small size compared to the major planets, Makemake is still large enough to have formed a spherical shape under its gravity, which is one of the defining characteristics of a dwarf planet. Mike Brown and his team at the California Institute of Technology, Caltech, played a pivotal role in the discovery of Makemake. Brown had already made headlines for his discoveries of other distant objects, including Eris, which had briefly caused Pluto to lose its planetary status when it was initially thought to be larger than Pluto. His work, along with that of other astronomers such as Chad Trujillo and David Rabinowitz, contributed significantly to the discovery of many Trans-Neptunian objects, which led to the reclassification of Pluto as a dwarf planet in 2006. The Palomar Observatory, where Makemake was discovered, has long been a hub for astronomical research. Located in the mountains of Southern California, the observatory houses several important telescopes, including the Samuel Oschin Telescope, which was used to discover Makemake. This telescope, which has been in operation since 1949, has been instrumental in the discovery of many objects in the solar system, including comets, asteroids, and trans-Neptunian bodies. The discovery of Makemake was part of a broader effort by astronomers to study the Kuiper Belt and its contents. In the early 2000s, as observational technology improved, astronomers began to realize that the Kuiper Belt was populated by a vast number of objects, some of which were large enough to rival Pluto. The discovery of Makemake further emphasized the importance of this region in understanding the formation and evolution of the solar system. Makemake is a fascinating object with many unique characteristics that distinguish it from other celestial bodies. It is primarily composed of rock and ice, with a surface that is mostly covered by frozen methane and nitrogen. The presence of these volatile compounds suggests that Makemake may have once been much warmer in the past, and its current frozen state may be the result of a slow cooling process over billions of years. One of the most intriguing aspects of Makemake is its lack of a known moon. Unlike other large objects in the Kuiper Belt, such as Pluto, which has several moons, the absence of a moon suggests that Makemake may have been impacted by another object in the past, and any potential moons it may have had could have been destroyed or ejected from its orbit. This adds to the mystery of Makemake's history and raises questions about its formation and the processes that shaped its current state. In terms of its orbit, Makemake follows a relatively circular path around the Sun, which is characteristic of many objects in the Kuiper Belt. Its orbit is slightly inclined relative to the plane of the solar system, and it takes about 310 years to complete one orbit. This long orbital period means that Makemake has only recently been in the same region of space as it is today, and it will not return to its current location for many centuries. One of the most notable features of Makemake is its lack of an atmosphere. Unlike Pluto, which has a thin atmosphere made up of nitrogen and methane, Makemake's surface is exposed to the harsh conditions of space without any protective layer. This lack of atmosphere contributes to the extremely low temperatures on Makemake's surface, which can drop to as low as 240 degrees Celsius, 400 degrees Fahrenheit. Despite the extreme cold, scientists believe that Makemake may still contain a small amount of internal heat, which could help to maintain some of its icy surface features. After its discovery, Makemake was initially classified as a potential planet, but further observations and analysis led to its reclassification as a dwarf planet. This was due to its size, shape, and the fact that it had not cleared its orbit of other debris. In 2008, the International Astronomical Union officially recognized Makemake as a dwarf planet, along with Eris, Haumea, and Ceres. The reclassification of Pluto in 2006, followed by the discovery of additional large objects in the Kuiper Belt, raised important questions about the definition of a planet. The IAU's decision to create the category of dwarf planet allowed for the recognition of these objects as distinct from traditional planets, while still acknowledging their importance in the broader context of the solar system. Makemake's status as a dwarf planet places it in the same category as Pluto, Eris, and Haumea, all of which are located in the Kuiper Belt. While these objects are not considered planets in the traditional sense, they are still of great scientific interest and contribute valuable information to our understanding of the solar system's outer regions. The discovery of Makemake has had significant implications for the field of astronomy, particularly in our understanding of the outer solar system. Makemake, along with other objects in the Kuiper Belt, has provided important clues about the formation of the solar system and the processes that led to the creation of planets and other celestial bodies. These objects are considered to be remnants from the early solar system, and studying them can help astronomers piece together the history of our cosmic neighborhood. In addition to its scientific importance, Makemake's discovery also sparked renewed interest in the Kuiper Belt and its many mysteries. As telescopes continue to improve and more objects in this region are discovered, astronomers are gaining new insights into the composition, structure, and dynamics of the outer solar system. This has led to the development of new theories about planetary formation, the role of icy bodies in the solar system, and the potential for life beyond Earth. The discovery of Makemake is just one example of the ongoing exploration of the outer reaches of the solar system. As technology continues to advance, astronomers are finding new and exciting objects that challenge our understanding of the cosmos. While Makemake itself remains a distant and relatively unknown object, its discovery has opened the door to further exploration of the Kuiper Belt and the many mysteries it holds. In the years since Makemake's discovery, astronomers have continued to study the object using a variety of observational techniques, including telescopes in space and on Earth. These observations have provided valuable data on Makemake's size, composition, and orbit, and they have helped to refine our understanding of its place in the solar system. Ultimately, the discovery of Makemake represents a milestone in the ongoing quest to understand the outer solar system. As new discoveries are made and our knowledge of the universe expands, we are continually reminded of the vastness and complexity of the cosmos and the importance of exploring every corner of it.